Okay, we are on to question number 33, where we have to find the equation of the diagonals of the parallelogram PQRS, whose vertices are given. So, for question number 33, part A, let's say this is a parallelogram PQRS with given coordinates, and P is 4 2 minus 6. Q is 5 minus 3, 1, and it's 12, 4, 5, and it's 11, 9, 8, minus 2. Okay, so we have to find the equation of the diagonals, and equation of the diagonals, this is passing through 2 points. So equation of VS, which is passing through 2 points, is given by x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. So let's put in the values of x1, y1, z1, and x2, y2, z2. So this is now x minus x1 minus 4, and so 12 minus 4 is 8, y minus y1 minus 2, 4 minus 2 is 2, z minus z1, which is plus 6. So this is z plus 6, and 5 minus or minus 6 is 11. This is the equation of the diagonal PS. Similarly, equation of the diagonal QR as it's passing through 2 points is, this is x minus x1 is 5. So x minus 5 upon 11 minus 5 is 6. Y plus 3 upon 9 minus or minus 3 is plus 2. And z minus 1 upon minus 2 minus 1 is minus 3. Okay, let's say, so these are the equation of the diagonals. And let's say this is equal to some constant k, and this is equal to some constant t, and for some values of k and t, let's say, so let's get the general points of for diagonal ps, and this x is equal to, if we equate this with the k, so this is equal to 8k plus 4, and y is equal to 2k. So this is for diagonal ps, the general points. These are the general points that lie on diagonal PS for some value of k. So y is equal to 2k plus 2, and z is equal to k. It's z is equal to 11k minus 6. Similarly, the general points for diagonal QR is equal to x is equal to 6t plus 5, and y is equal to 12t minus 3, and z is equal to minus 3t plus 1. For some values of k, let's say these are the point of intersections of these two diagonals, and point of intersection of diagonal means that x and y coordinates are same. So let's equate them. So 8k plus 4 is equal to 6t plus 5, and let's equate the next one. 2k plus 2 is equal to 12t minus 3. So this becomes 8k minus 6t is equal to 1, and 2k minus 12t is equal to minus 5. So this is equation 1 and 2, and solving 1 and 2, let's multiply 1 with 2, which gives 16k minus 12t is equal to 2, and 2k minus 12t is equal to negative 5. This is negative plus plus. So this gets cancelled. 16 minus 2 is 14k, which is equal to 7, and k is equal to half. Similarly, we can get the value of t. So from this, we can get the value of t. So 2 into half minus 12t is equal to negative 5. This gets cancelled. 1 minus 20 is equal to negative 5 minus 20 is equal to negative 5, negative 1. So 12t is equal to negative 6. and t is equal to half. So t and k are both the values are half. So now let's find out the point of intersection of diagonals by replacing the values of k and t. So point of intersection of diagonals, we can take any of these points. So let's take these points. So if we replace the value of t, so x is equal to 6 into half is 3 plus 5 is 8. Y is equal to 12 into 3, 6 minus 3 is 3, and z is equal to minus 3 into half is minus 3 by 2 plus half is negative half. So point of intersection of diagonals is a, 3, and negative half. Okay, and let's move on to the next statement. So using these equations, find the point of intersection of diagonals. So we are done with the part A. Let's move on to part B. Part B says that a line passes through point. So a line L, it passes through the point minus 1, 3, minus 2, and is perpendicular to both the lines. So there is a line L that is perpendicular to two lines. Okay, this is perpendicular to two lines, and this line L is passing through minus 1, 3, and minus 2. Okay, so this is x by 1 is equal to y by 2 is equal to z by 3. And this is x plus 2 by minus 3 is equal to y minus 1 by 2 is equal to z plus 1 by 5. Now, equation of a line passing through a point, we know that equation of a line passing or even point is given by the equation x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. The equation of the line is x minus x1 is minus 1, so this is plus a, and y minus y1 minus b by b, and z minus z1 plus 2 by c. So let's say this is the equation of the line, and now line L is perpendicular to, let's say this is line 1 and 2. So line 1 is x by 1 is equal to y by 2 is equal to z by 3. So that means the sum of the product of the dash and cosines of L, and this will be 0. So this is a into 1 plus b into 2 plus 3 into c is equal to 0. So a plus 2b plus 3c is equal to 0. Similarly, L is perpendicular to the next line of this face x plus 2 by negative 3 is equal to equation of the line is y minus z by 2 and z plus 1 by 5. So sum of the product of the direction cosines, direction ratios of these will be equal to 0. So this is minus 3b plus 2b plus 5c is equal to 0. And let's try to solve these equations by cross multiplication method. So let's try to solve this equation by cross multiplication method. These equations have the variables a, b, and c. So this is a, b, and c, and hide the a terms, which gives me 10 minus 6 is equal to b. Hide the b terms, which is minus 9 minus 5 is equal to c. Hide the c terms, which is 2 plus 6. 2 plus 6. Let's say this is equal to some constant k. So a is equal to 4k, b is equal to negative 14k, and c is equal to 8k. So these are the direction ratios, which are 4k minus 14k and 8k. And we know the direction ratios are the multiples of some constant. So let's take out the constant k and 2, which will give us 2, -7, and 4. So these are the direction ratios of the line. So now it's been asking the question to find the vector equation of a line. So vector equation of the line is r vector is equal to a vector plus lambda into b vector, where a is the position vector of the point through which this line is passing. So minus I plus 3j minus 2, minus I plus 3j minus 2k cap plus lambda into b. B vector is the line to which the given line L is parallel, and it has the direction ratios 2, -4, and 7. So this is 2I cap minus 7j cap plus 4k cap. So this is what was asked. And now we have to find the distance of this line from the origin. So let's say this is the space and this is the line. This is our line L. This is the origin with coordinates 0, 0, 0. And this is the line L. We have the vector equation of the line L. And we have to find its distance, that is the perpendicular distance from the origin. Distance means the perpendicular distance from the origin we have to find. Okay, now, so this equation, this line is passing through the point -1, 3j minus 2k. So we have to find it's not necessarily that it's the perpendicular distance from the origin. We have to find its distance from the origin. So the distance from the origin would be the distance between any 2 points that we take on line L. So line L is passing through, it's passing through -1, 3, and 2, and its vector position is minus I cap plus Pj cap minus 2k cap minus 2k cap. And the vector position of the origin is 0I, 0j plus 0k cap. Let's say this is a2 vector and this is a1 vector. Now the distance from the origin is given by a2 minus a1 vectors cross with b vectors magnitude upon the magnitude of b. Now a2 minus a1 is I cap minus 3j cap plus 2k cap into the b vector is crossed. The b vector is 2I minus 7j plus 4k caps magnitude with the magnitude of b. So magnitude of b is 2 square 4 plus 49 plus 4 square 16. Let's find out the cross product. So the cross product of I cap minus 3j with 2I cap minus 7j cap plus 4k cap. So this is equal to I cap, j cap, k cap, and it is 1 minus 3, 2, 2 minus 7, and 4. Okay, so this is 1 and it's -12 minus 12 and plus 14, -12 and plus 14 minus j cap, which is 4 minus 4 plus k cap minus 7 plus 6, which gives us 2I cap. This is 0 and plus k cap. So we have to find its magnitude. So the magnitude of this is under root 4 plus 1, which is equal to under root 5. Now, so this is under root 5 and this is under root 4 plus 49 is 53 plus 16 is 69. So this is under root 5 by 69 units. So this is the perpendicular distance, and we have almost solved whatever was asked in the question number 33. We have obtained its distance from the origins. So question number 33 is done. Let's move on to question number 34.